Good evening, everyone, and welcome to the virtual public informational meeting for state project number 1-108, rehabilitation of bridge number 4582 on Long Hill Road over the Hop River in the town of Andover. You can reach the project team by these contact prompts below between email, phone, and we encourage you to visit the project webpage. Here's a quick slide on how to use the view captions and subtitles in Zoom. There's a pop-up on the bottom of the screen for the speaking language. Closed captioning is also available on YouTube after the event. After the presentation, there'll be a Q&A session, and this is how to use the Q&A in Zoom. There's a Q&A tool at the bottom of the Zoom webinar. The window will open, and then you can type in your question. If you're listening by phone and are an audio-only participant, please dial *9 to raise and lower your hand. Some quick overall meeting goals. We're going to have some housekeeping. We're going to explain the project funding and the federal local bridge programs design managed by state, or DMS program. We'll be welcoming remarks from the town of Andover, town administrator, project team introductions, and then a formal presentation of the design process. We will define the project purpose and need and describe existing conditions and present our proposal. Please keep in mind our design plans are only at 30% at this point, and then there'll be a live Q&A session with interactions of the project team. I should have stated this previously. My name is Mark Burns. I'm the project manager for the department's local bridge program, and this is my contact information. To reach us through question and answer session, you can email us at dot-flbp@ct.gov, by phone at 860-594-2020, by chat in the Zoom Q&A, and you can also visit the project web page. Please note the comment period is open through July 23rd, 2024. I will now read this slide on Title VI, Civil Rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out the voluntary post-meeting survey using the QR code or link below. And then there is another link to the Office of Equity's Title VI Civil Rights information. A recording of this presentation will be posted to YouTube after the event. Closed captioning, including non-English translation options, are available on Zoom and YouTube. This is a slide, I won't read this, but this is a slide on the Title VI notice to the public. Funding for this program is through the Federal Local Bridge Programs Design Managed by State, or DMS program. In the past, bridges under the Federal Local Bridge Program were funded 80% federal, with federal funds, and 20% municipal or town funds for design, rights-of-way, and construction. In the Design Managed by State, or DMS program, design, rights-of-way, and construction phases are funded with a minimum of 80% federal dollars and up to 20% state dollars. Design is at zero cost to the town. Now, despite the department taking over the design, it is still a full partnership with coordination with the town, and we solicit their input at major project milestones such as this one. The goals of the DMS program were to provide a streamlined approach to design using full DOT resources, aid municipalities in keeping their bridges in a state of good repair by effective use of funds, and to decrease typical design time of upwards of 60 months to 36 months. And when possible, utilize accelerated bridge construction, or ABC techniques, to shorten construction duration. I'll now quick turn over to some remarks from Eric Anderson, the town administrator for the town of Andover. Eric. You might be on mute, Eric.
Thank you, Mark. On behalf of the town of Andover, I would like to thank DOT and specifically Mark Burns, as well as Close, Jensen, and Miller for their help of the town of Andover in this project. As most of you know, small towns have very limited resources, and the ability to work with the state to bring a major bridge project through to completion is a really wonderful thing. So we're very fortunate to be in the design managed by state plan. And we're quite fortunate to work with Tom Weldon and the team at DOT to pull this off. So with that said, I turn it back to you. Thanks, Mark.
Thank you, Eric. I'll now introduce the project team between the department and the department's liaison engineers, Close, Jensen, and Miller. Bart Sweeney is our division chief of bridges. Derek Lassard is the principal engineer of the consultant bridge design unit. As I said, my name is Mark Burns. I'm the project manager. Michelle Rain is the project engineer from the department. And then representing Close, Jensen, and Miller are Jim Platosh, project manager, and Bob Kosker, liaison engineer. This is a brief slide showing the key structural elements of a bridge. Carrying vehicles and pedestrians in intermodal traffic is the deck. You'll also see parapets on top of the deck, which protect vehicles and pedestrians from any roadside hazards. Supporting the deck and parapet is the superstructure. In this case, it's made out of steel beams in the diagram. Supporting the superstructure will be the abutment or substructure, which will then also have wing walls for earth retention. And there will be some type of footing, whether it be a spread concrete footing or some sort of pile system. In this diagram, there's also a pier, which will periodically be used depending on the span of the bridge. Conditions of all the key elements are rated on a scale of 1 to 9, with 9 being in excellent condition and 1 being an imminent failure. But don't let that scare you, because the bridges are in the state are inspected on a biennial basis, and if there was any issues, the towns would be alerted to take any corrective action. Here's a quick slide showing some examples of concrete deterioration. Efflorescence in the top left is when water evaporates and salt starts to appear on the surface of concrete. Honeycombing is usually a result of workability or improper setup of concrete, resulting in it not setting up completely and filling a form. Scaling is when surface cracks appear due to freeze-thaw actions. Map cracking is when top surface drying or thermal reactions happen, resulting in cracks. And then a more severe case of map cracking is known as spalling, when the freeze thaw has gotten further into the reinforcing steel, as shown in the bottom right picture. I'll now turn over to Bob Kosker for the formal presentation. Bob?
Thank you, Mark. My name is Bob Kosker. I am a project engineer, liaison engineer with Close, Jensen, and Miller. And our role is to administer and provide technical support to the Department of Transportation. Going to define the purpose and need of this project right now. Basically to address the structural deficiencies by replacing this 90-year-old bridge, and to provide a bridge that's in a state of good repair. There are also some hydraulic efficiency issues with this bridge's ability to pass the flow of Hop River, and we also want to provide a bridge that is stable for predicted scour. And scour, kind of in a nutshell, is a localized loss of soil or channel material around a foundational element. And it's usually caused by turbulent, high velocity water flow or swirling action of the water. It's actually the most common cause of bridge failure in the United States. I read I think more than 60% of bridge failures are caused due to scour issues. The need for the project is the reinforced concrete deck is in poor condition. And as Mark was explaining, that received a condition rating of 4. And as I just spoke about, the structure is scour critical, which basically means that the foundation is susceptible to undermining and it's not stable for predicted scour conditions. So we want to address that issue. I already talked about the need for some improvements to the waterway capacity. Also, we'd like to add some safety for pedestrian traffic that tends to be in the area. Project location, there's a map here. It's about 555 feet north of US Route 6. It is classified functionally as a rural local road. So it basically serves the local community. And here's an aerial view of the site with some of the surrounding properties noted. Almost all of them, except for the 5th noted here, the Congregational Church, they are town facilities. The Long Hill Road, just to establish, runs north and south, and Hop River flows from west to east. And basically the area on the east of the roadway there and bridge is primarily just wooded floodplain. Just a little history on the bridge and the existing conditions. It was built in 1934, so like I said, it's 90 years old, and the type of bridge, it was a reinforced concrete T-beam superstructure, which named so because of the shape that the concrete beams took when they were erected, and there is a poured concrete deck slab on top of that, and it's all overlain with bituminous concrete or asphalt. The abutments in the wing walls, which are part of the substructure, they are also reinforced concrete. The span of the bridge is 40 feet across the river, and the total from back of abutment to back of abutment is about 43 feet. The bridge provides a 30-foot wide curb-to-curb roadway width, which is basically 15 feet for each direction of traffic. There are currently no sidewalks on the bridge. There's a concrete parapet that is open, and the bridge carries an average daily traffic, abbreviated ADT, about 400 vehicles daily. Posted speed limit out there is 30 miles an hour. And we've got quite substantial right-of-way out there. It's 80 to 100 feet wide at the bridge. So it's about 40 to 50 feet on either side of the roadway center line. Utilities out there are located on the west side of the bridge, as shown here. And they consist of electric distribution wires, telephone wires, and cable television wires. Going to go through briefly the various components of the bridge itself and just some of those ratings that Mark identified earlier. The approaches are basically just the roadway adjacent to either side of the bridge. That is rated a 6 in satisfactory condition. Basically, it has some substandard guide railing, and the approach pavement, as you can see, it's in pretty poor condition. The driving deficient element, I'll say, for this project is the reinforced concrete deck. It's rated as poor, and you know, I can list all the specific defects associated with it, but I think the picture here tells the story better than anything. I believe that's the northwest corner of the bridge, and you can see that the deck itself beyond the bridge railing is just kind of crumbling. The superstructure, or the beams which support that deck, they are rated in fair condition. However, as you look at the photograph, the deterioration is advancing. There's lots of cracks, scaling at the water line. Basically, all of those concrete deterioration that was highlighted previously, you can find it here. So it's not a short, it's kind of a short progression from the fair condition that it's in right now to being in poor condition, similar to the deck. And the substructure, which includes the abutments and wing walls. They're also in fair condition, but similar to the superstructure, the deterioration is advancing, and that could very easily, they could very easily become a 4 poor condition rating. I mean, they are 90 years old, and for that age, they've held up well, but they just kind of have outlived their life expectancy. Here's just some more photographs of the substructure and some of the deterioration that's present there. The condition of the river channel is also rated. It's rated in 5 as a a 5, which is fair condition. And as I've discussed before, the scour rating is 3. It makes it scour critical. And you know, there's quite a bit of evidence of scour on the embankments. There's also some buildup of sediment that is actually removed from the channel as part of the scour mechanism. And there's a lot of scour present at the center line of the channel through the bridge and along the south abutment. There's some pretty sizable scour holes. Hydraulically, you know, there's a lot of wording on this slide, but I think the important thing for you to know is that it is susceptible to flooding during significant or design storm events, we call them. And there's a photograph here which shows the bridge and roadway looking north during a fairly recent storm event. And the bridge is basically, it's barely dry, but just as you progress to the north, Long Hill Road is underwater, or it's flooded to a degree. So we performed a subsurface investigation to determine the consistency of the subsurface, basically. And what we found was that bedrock is present at about at all 4 of these boring locations between 50 and 65 feet below the roadway surface. So we do have some good foundation material present at the site. Given all the existing conditions, we decided, and it is proposed, to replace the bridge in its entirety. We plan to do that using precast, pre-stress, what's called concrete box beams. They're shown in this diagram at the bottom of this slide, and that is in keeping with using accelerated bridge construction methods. They're precast and can be placed rather quickly. On top of that, there is a concrete shear slab, and the beams themselves are protected from water intrusion by installation of a waterproofing membrane and asphalt on top of that. There's a 3-inch layer. As I said, the shear slab itself, it protects the primary beams themselves from water infiltration. It also protects it from, if you got to replace the pavement on the bridge, you may have to mill it off and then repave. So it protects the beams themselves from being damaged by any milling and paving equipment. Okay, so these are some proposed preliminary plans of the roadway and bridge itself. And one thing that is notable is there is a sidewalk on the west side of Long Hill Road that runs from the public library to the termination at the driveway to the Public Works facility. Just on the other side of the bridge is the parking lot for the town ball fields, and there currently isn't a sidewalk there. We propose in building the replacement bridge to add a sidewalk from its current terminus south of the bridge and extend it across the bridge all the way to the entrance to the parking lot for the town recreational facilities. So this is what's showing in plan view. There's a legend on the left side which shows the proposed bridge in orange and the various other features, obviously blue for the waterway. Yellow is reconstructed pavement. The gray is existing pavement, and so forth. This is a representation of the roadway, what we call profile, which essentially it's an exaggerated scale, but what's primarily important to know from this slide is, I guess, first of all, you can see we've expanded the length of the bridge substantially. The proposed bridge is shown in orange. We've extended it, doubled it basically. We're going from 40 feet to 80 feet long. However, we are still essentially maintaining the vertical profile of the bridge. So in other words, really the pavement elevations aren't going to experience any noticeable change. And as you can see here, we've gone from a 40-foot clear span to an 80-foot clear span. This is an elevation view of the proposed bridge, looking at the downstream or east side of it. And by replacing this bridge, just wanting to point out some of the improvements we will achieve to the current hydraulic condition. We're making the opening quite a bit larger than the existing. We're doubling it. And so what that will result in is we're going to alleviate the current pressure flow at the bridge. Pressure flow being that the underside of the superstructure itself, or the horizontal top part of the bridge, there's actually water that wets the structure itself, the superstructure. So we've eliminated that for our design storm condition, and we've improved the overtopping such that it doesn't occur so frequently. And we are going to provide a bridge that is stable for predicted scour. In order to construct the replacement bridge, we are going to close Long Hill Road at the bridge and implement the detour shown here. It's a little over 5 miles long and includes Long Hill Road, Hendy Road to the north, and US Route 6. Oops. Okay, permit and environmental considerations associated with the bridge replacement project. The permits we expect are an inland wetlands and watercourses commission permit from the town of Andover, flood management certification from the Connecticut Department of Transportation, and that is under a memorandum of understanding with Connecticut DEP for issuing flood management certification for municipal projects that have state and federal funding associated with them. It's intended to streamline it and probably accelerate the ability to procure permits. Also, U.S. Army Corps of Engineers general permit will be required. A couple of the associated aspects that are related to permitting that we know now is we've consulted the Connecticut DEP Natural Diversity Database, and we found that there are quite a few species that are either of special concern to the state, and one that is on the federal endangered list. And they're listed here. You got quite a few snakes and bats in particular. Because of that, we intend to engage a herpetologist who's going to be hired to work on site to make sure that we mitigate any potential harm to these species. And we've also considered Connecticut DEP Fisheries Division, consulted them, I should say, and they have recommended that we minimize any proposed bank stabilization material so that we don't adversely affect any fisheries resources. Now, with respect to both the NDDB species and the DEP fisheries agencies, there are going to be restrictions imposed, and they're time of year restrictions when you can't conduct certain work. With fisheries, it's related to the unconfined in-water work, which is generally not allowed from June 1st until September 30th in any given year. However, with the specific time of year restrictions that may be imposed relative to the NDDB species, coordination needs to continue. So we do have a workable period for construction. So that we'll be engaged in that during the final design phase of the project. Just going to just about wrapping up with the estimated construction cost at this point, the schedule, and just some final presentation remarks. The replacement of the bridge, the project is anticipated to cost about $4.1 million. Now that amount includes not only the physical construction work, but it also includes incidentals such as construction inspection costs, oversight by the state DOT, materials testing, things like that. So all told, it's about $4.1 million at this point. The duration of the project, we anticipate to be about 6 to 8 months, with a start scheduled for the spring of 2026 and an anticipated completion in the fall of 2026. Just to close out, as part of the construction, we will need to relocate those overhead utilities on the west side of the bridge to ensure that we have clearances to various construction equipment and so forth. And I mentioned earlier, but we're very fortunate that we don't need any rights of way acquisitions, because there is so much available town right of way here. So basically, it's a fairly straightforward project, and I thank you for your attention, and I'm going to turn it back to Michelle Rame for questions. Thank you.
Thanks, Bob. Great job. So we're going to move on to our live question and answer section of the presentation. I just want to reiterate that you can submit questions right now during this live chat until the end of our presentation. You can submit questions to our email, dot-flbp@ct.gov, or by phone at 860-594-2020. Our comment period is open through July 23rd, 2024. I have no questions as it stands right now, but we'll leave it open. Hey, Bob, do you want to go to the next slide? So you put that slide up there so people can see it.
Oh, yes.
Yes. Just so you know, the chat is at the bottom of your screen, and that's how you submit your questions through the live chat. We have our first question. Oh, we have a couple coming in. Will the road closure be for the entire duration of the project?
Yes, Michelle, I could answer that. As you heard Bob mention, it's anticipated to take between 6 months and 8 months to construct the bridge. And the simple answer, yes, it will be closed during that entire duration.
Thanks, Jim. Our next question, will the state at least temporarily put a light on Hendy and Route 6 for the traffic as there is now?
Michelle, I could answer that. Part of the design of the detour includes assessing what we call reassignment of traffic volumes, meaning the traffic that is on Long Hill Road today will, of course, be detoured on the Hemby. And as we might expect, there will be an increase at the intersection with Route 6. So part of our design will include evaluating the impact of reassigning those volumes and to see if it meets warrants. Those that are familiar with signal design know that there are certain volume warrants that are needed to be met in order to justify a signal. So as I mentioned, as part of the design process, we will certainly consider the impact of traffic and the need for a signal.
Thanks, Jim.
Folks, if you have any other questions, now's the time to ask them.
Should also keep in mind too, if you can think of a question later, our comment period is open until July 23rd.
And there is lots of great information on the project webpage, plans, and information that you found tonight. All right, seeing no further questions, I think we are going to close up shop here. And again, I just want to reiterate, if you have any further questions, you can email dot.flbp@ct.gov until July 23rd, 2024. Call us by phone at 860-594-2020. Leave us a voicemail or check out the project webpage for great information there too as well. Thanks and have a great night.
Thank you.